purpose of this lesson is to not solve the whole problem. We're going to look at a series of introductory problems, introductory problems 2, and some of the ones beyond that, just to focus on the whole idea of understanding a pattern and how it grows. So this is intro pattern 2, and from one figure to the next, oftentimes students will notice that we're simply adding 2 more tiles onto the bottom from the starting figure. So figure 1, and then you add 2 to the bottom here, and then 2 more to the bottom there. And this sometimes leads to the confusion of the idea that the equation is simply x plus 2. But we're going to kind of deal with that misconception here in this lesson, trying to understand what it means when we add 2 each time to each new figure. So we start with this original one that has 3 tiles in it. So I'm just going to write that on here. Figure 1 has 3, and then figure 2 has 5, and then figure 3 has 7 in it. So it should be obvious that we're simply adding 2 more to the bottom each time. Now that's a significant number, knowing that we're adding 2 each time to the next figure, but that only helps us identify what's next and not the overall picture of what's happening. So I want to go to the additional figures in the pattern. Here's figure 4, which if we continue, so we added 2 more to the bottom here in figure 4, and so that one has 9, and figure 5 has 2 more, so that'd be 11, and figure 6 has 2 more, which would be 13. So again, the idea that we're adding 2 to the bottom of each figure to get the next figure. And that is significant, but I want to look at, so we found the 6th figure is 13. We just did that one up here. I just did that one. And then the 10th figure is 21 if I just continue the pattern of increasing by 2 each time on my table. And so you can see that there's 2 more for each figure. So we're adding 2 to the previous figure to get the next figure. And that number is going to be important here in just a second. So from here to here, every time we're just increasing by 2. So we can see that continues all the way through. But it's better, rather than to focus on what it's increasing by, is what you actually see. And so in this case, I want to go back to the original pattern and just look at what I see. I see a stack here of 2 tiles and a stack here of 1 tile. And I see a stack of 3 and a stack of 2 and a stack of 4 and a stack of 3. Those combinations, the 2 and 1 make the 3 and 2 make the 5, the 4 and 3 make the 7. That's what I see in the problem. And if I continue that to figures 4, 5, and 6, what do I see here? 1, 2, 3, 4, 5, and 4. And then I see in figure 5, there's 6 there, and 5 there. And in figure 6, I see 1, 2, 3, 4, 5, 6, 7, and this side 6. So what I see are these stacks of 5 and 4, 6 and 5, 7 and 6, and I just translate that down into my what I see chart. If I had a figure 0, it'd be a stack of 1 and then 0 next to it would just be 1 tile. And then figure 1, there's my 2 plus the 1. Figure 2 is 3 plus 2. Figure 4 is 4 plus 3. Figure 4 is 5 plus 4. And so on down the list. And the pattern here is actually more useful than the pattern over here. I know it goes up by 2, and that is helpful to be able to find the next figure, and so is this, because I can look at, see, I have 2 plus 1, 3 plus 2, 4 plus 3, etc. on down. That's what the stacks are. So when I get to the 30th figure, I know I'm going to have 31 plus 30 because this number has always been 1 greater than the figure number. And here's the key. The figure number represents the letter x in our equation, and the number of tiles represents the letter y. And really what we want to do is always go back to the figure number as our x, or as the variable. The figure number is what's changing. And so what I want to do is I want to figure out how is the figure number related to the total number of tiles. And I can see it in the what I see section here, because what I want to do is see how these numbers, the figure numbers, relate to the what I see numbers. So in the case of here, if you look at the what I see numbers and the figure number, here's figure number 1, and I have a 2 plus a 1. And if we think of this as equal to x, in this case, x is 1, and then x is 2, and then x. See, x is a variable. X is a changing value. X represents the figure number as it changes. So figure 0 is when x is 0. Figure 1 is when x equals 1. So I could say x equals 1. So in this case, that's the same as x right there. That equals x. But that equals 1 more than x. And right here, if x is 2 in figure 2, then that right there is 1 more than x, and this is the same as x. And if I keep going down, in this case x is now 3, because x is changing as the figure number changes. And so in this case, here's an x plus a 1, and here's another x. And that just continues all the way down. Every time I look at this, in this case, whatever x is, this number here is x plus 1, and this number here is x. So if I take x plus 1 plus x, whatever x is, in this case if x is 30, it's 31 plus 30 equals the number of tiles. And so right there is my equation. This is the variable, the figure number. That's what's changing. And as the figure number changes, so does what I see. And the part about this that's important is that now I can actually go back to the original figures and see that here, if the figure number, this is equals x, this equals x is 2, x is 1, x is 2, x is 3. And so in that case, that means this is equal to x, and this is x plus 1. And here's an x, and here's an x plus 1. See, if x is 2, then this is x plus 1. If x is 3, then here's an x, and here's a x plus 1 equals the 4. So right here, I have, represents, and this is the contextual, this is the context of this equation. I actually have an equation that says x plus 1 plus x equals y, equals the number of tiles. X is the figure number. And so here's the x plus 1 part, right here. And here's the x part right here. It's equal to the figure number. Same is true in each of these. Here's an x plus 1. And here's an x. So now you can see that my equation, x plus 1 plus x. Now some people like to write this equation a little bit differently. They say, well, really, you could think of it this way, because there's more than one way to think about this. You can think of this as two sets of x. So you could have all of this right here, where I have all of this is equal to x, and here's another x, and then plus the 1 on top. So I could think of it this way as a x plus 1. So I have the x here, that part's equal to x, in this case x is 6, and here's another 6. So there's another x. So x plus 1. Which is really not any different than what I have down here because I have an x plus 1 plus x. I just changed the order. It just depends on how you see it. So you could see 2 sets of x plus the 1. Which means I could also have just written it this way. 2 times x, when you put a number in front of a letter, that's multiplication, plus 1. In both cases, these equal y. Now here's the important part of this plus 2. If you know that you're adding 2 every time, it tells you how many x's you're going to have in your equation. Since it goes up by 2 every time, I know that I'm going to have 2 x's, which is what I ended up with here. Some people make the mistake of thinking the equation is x plus 2. The plus 2, when it goes up by the same amount every time, is simply telling me how many x's there will be in the equation. So if I see it goes up by 2 every time, I'm going to look for 2 x's somewhere in the pattern. Now what I want to do is move to intro problem 3, because I want to use the same technique that I just showed you to show you this problem. So if we look at this one, some of you might realize that from figure 1 to figure 2 to figure 3, we're just adding 3 to the bottom each time. It's a very similar problem to intro pattern 2. In intro pattern 2, we're just simply adding 2 to the bottom each time. But now we're adding 3 onto the bottom of each of these. Each time there's 3, and so when we look at these 3 figures, and then if we continue to figure 4, 5, and 6, you can see that there's each time we're just simply adding 3 more to the bottom. And so if we just look at how many are in each of these, this one has 5, and then this one has 3 more, which is 8, and this one has 3 more, which is 11. And if we keep going into figures 4, 5, and 6, so now we have 3 more than we had before, so now we have 14 here, and then 17, 3 more on the bottom, and then 20 in these. And so I can make my table that goes 5, 8, 11, 14, so going up by 3. See, so we go plus 3 each time. Now, I just said in the last one that if I know it goes up by the same amount each time, my equation is not x plus 3. What it's telling me is that there's 3 x's in this equation. And so what I really want to look for are 3 figure numbers. Since x is equal to the figure number, so we can think of this table here, figure number that equals x. And as x changes, as we look at a different x each time, the value of x changes with each figure, just like the number of tiles, which is our y, changes. So what I see in this case, I see a stack right here that's too high. I see a stack on this side that's too high, and then there's one more in the middle. And then I see a stack of 3, a stack of 3, and then 2 in the middle. And as I do that, I'm trying to think about the figure number and how these numbers relate to that figure number. So I'm always looking for the figure number because that's x, and that's x, and that's x. See, x is always the figure number because that's what we've defined it as. And so as I look at this pattern, I see 3 stacks. And there's other ways to see this, but this is just the way I'm seeing these 3 stacks. So in this case, here's a stack of 2, a 1, a 2, a 3, a 2, a 3. So in each of them, you're seeing that same pattern in the stacks. When I look at figure 4, here's a stack of 5, a stack of 5, and then a stack of 4 in the middle. And then another stack here of 6, stack of 6, and a stack of 5 in the middle. Now on figure 6, if I just say that x is equal to 6, because in this case x was equal to 5, in this case x was equal to 4. Remember, x is the figure number. That's what we define it as in all of these types of problems. So if I look at this stack right here, that stack is 1, 2, 3, 4, 5, 6, 7. It's one more than that, so it's x plus 1. If I look at this stack, it's the same as that one. It's one more than the figure number, so x plus 1. And if I look at this center stack, which is 6, it's equal to x. And so really this is the context of the equation that we're going to come up with, because the context of this is you have a stack of x plus 1 plus a stack of x in the middle plus another stack of x plus 1 on the outside. And if you look, I have 1, 2, 3 x's. And if you look at what it goes up by every time, it goes up by 3. And so that number told me that I should expect 3 x's in my equation. Now we could put this together. Some people actually look at this problem like this. You could think of it as right here, if I were to take, and that set right there, there's 1, 2, 3 sets of 6, or 3 sets of x. So here's an x. This whole part here is an x, and here's another x here, because x is 6 in this case. And here's another x. And so I have 1, 2, 3 x's plus those extra 2. So this really could have been written 1, 2, 3x, 3 times x, plus, put those two together. And so that's another way to write this, 3x plus 2 equals y. But again, there's 1, 2, 3 x's plus the 2. There's the x plus 1, an x plus 1, and an x in the middle. And so when I'm thinking of the equation for this, if this is x, this right here is x plus 1, 31, and then I have the x in the 30, and another x plus 1, and that equals the number of tiles for that figure. So any figure in this pattern, if I want to find it, I could have simplified this to 1, 2, 3x plus 2. Those two equations are equivalent. This one's a kind of combined version, put the x's together. But that 3 told me how many x's I should have in my equation. So I'm going to do this one more time and see if this makes sense. So intro pattern 4. Let me look at one more real quick. So intro pattern 4 and intro pattern 3 are very similar. In figure number 1, there's 4. In figure number 2, you can really think of this as 1, 2, 3, 4, 5, 6, 7. So they're adding 3 more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So when I look at figures 1, 2, and 3, they're 4, 7, and 10 tiles. So it's going up by 3 each time. So we're increasing by 3. Figure 4, there's 3, 6, 9, 12, 13. And then 3, 6, 9, 12, 3, 6, 9, 12, 15, 16. So again, went up by 3. And so 3, 6, 9, 12, 15, 18, 19. And so you can see that it's increasing by, if I put these on my chart, it goes up 1, 4, 7. So we're going up by 3 each time. So plus 3, plus 3, plus 3. And what does that plus 3 tell me? It tells me there's going to be 3 x's in my equation, or x times 3 when I get done, every time from one to the next. Since it's going up by the same amount each time, it's a constant change. And so I know that when I look at my stacks here, right here I have 1, 2, 3, 4, 5, 6. That's the same as the figure number, so that's an x. And right here I have 1, 2, 3, 4, 5, 6, so there's an x. And right here in the middle, I have 7, which is an x plus 1. It's one more than the figure number. So I can do the same thing here. There's 1, 2, 3, 4, 5. That's the same as the figure number in this case. And remember, x is represented as the figure number. 1, 2, 3, 4, 5. There's another x. And in the center, I have one more than the figure number, so x plus 1. And now I was expecting 3 x's because it was going up by 3. And if I look at my pattern, I have, here's x is the figure number. And then I have x plus 1 plus x. So 30 is the same as the x. There's one more than the figure number. And then there's the same as the figure number. And that gives me my total number of tiles for any figure. And so this number tells you how many x's you should have in your equation. 3x plus 1 equals y. And you can see that up here. Sometimes people will say, well, there's really 3 sets of x in here. There's one x here, there's another x here, and there's another x here. 3x plus the 1. So always wanting to go back to what you see and then understanding how that identifies the patterns. This is the context piece. This is what context should look like. It should identify the equation, in this case, 3x plus 1, in context in the tiles. Or if you just wrote the equation x plus 1 plus x, you should be able to see each of these parts. There's the x, and in the middle part is the x plus 1. That's what we mean by showing an equation in context. How does this equation actually come from or fit the tiles or the pattern that it came from? I should be able to show that on any one of these. In this case, if x is 4, figure 4, there's an x. There's an x plus 1 in the center. And then again, a set of 4 is equal to the x. See, as x changes, so does the pattern. Because x is a variable. It's something that changes as the pattern itself grows and increases. And so whenever you look at a pattern, just throw one more up there for you. As soon as I look at this pattern, if all I can do is figure out how it changes from one to the next, that helps. So here's my table. So I can see it goes up by 3, up by 3. So immediately I know my equation is going to have 3 parts, or 3 x's. So I go back here and say, well, let's see, figure number 6, if x is 6, 1, 2, 3, 4, 5, 6, there's an x. And let's see, 1, 2, 3, 4, 5, 6, there's an x. And then 1, 2, 3, 4, 5, 6, there's an x right in the middle. And then I didn't get this one or this one, so those are leftovers. And so I think my equation is going to be y equals 3x plus 1. There's 3 x's plus 2. There's 2 left over there. And really, if I think about what I see, well, let's see, what do I see? Right here, I see 1, 2, 3, 4, 5, 6. Think of it this way. My figure number is 5, so that is x plus 1. And right here, I see 1, 2, 3, 4, 5, 6. How does that relate to the figure number? It's one more than the figure number. And in the center, I have 1, 2, 3, 4, 5. And so there, in the center, that's the same as the figure number. So what do I have? I have x plus 1 plus x plus 1, which is 1, 2, 3 x's plus 2. So really they're the same equation, just different ways of representing it, different ways of showing the same thing. And in my table, what did I see? I saw 2, then 1, then 2. So what I saw was in figure 4, I saw 5, 4, and 5. One more than the figure number, the same as the figure number, one more than the figure number. X plus 1 plus x plus x plus 1. So when I look at the figure number, I look at that, and that's one more than the figure number, x plus 1, plus the figure number, plus, and that gives me my number of tiles, and that again could be simplified, 1, 2, 3 x's plus 2 equals y. And that's what we mean by context. When you put an equation in context, you should be able to see it in the actual tiles that it came from. So this is represented here. This is represented here. And really every pattern problem can be solved if you can look for these types of patterns in what you see and relate it always back to the figure number. So I hope that helps as you continue to try to solve these types of increasing pattern problems.